Here's lesson 106, number 12. It says I'm supposed to develop an identity or something. What does it say? It says I'm supposed to develop a formula for the sum of n terms of an arithmetic sequence or series whose first term is a sub 1 and whose last term is a sub n. So I have to get the formula. Now you might already know that this is the formula right here. So that might help just to so that you'll know where you're going. And I just kind of want to remind you, I hope that I wrote that, I hope I said this in the video lecture, but let's look at it, before I show you the development of the formula, let's look at a series. Like, let's say this is an arithmetic sequence right here. Right, so it's got 3, 6, 9, 12. So it must be adding 3 each time, right? Does that seem pretty obvious? It's adding 3 each time. Well, it turns out that if I wanted to actually find out how much all these guys add up to, it's kind of weird how this thing works, but these pairs, if I take the first one and the last one, what's 3 plus 21? 24, right? Well, guess what? The next two pairs, the 6 and the 18, what do those add up to? The same thing, 24, right? And the 9 and the 15, those make 24. That one only makes half of 24 because I didn't have an even number. But so basically, because arithmetic series or sequences and series work like this, you can find the sum of it if you know the first term and the last term and how many terms there are. You can find out the sum, right? You can just add the first and the last terms and then divide it by 2, and then that's how much each pair will be, and then you multiply it by however many pairs there are. Or in other words, this. Right? That's saying that there's pairs, and this is saying how many pairs there are. Now, sometimes they don't pair up like that 12 in the middle, but this accounts for all that. So I don't know if that helps you understand what's going on here. So in your book, they want you to develop this thing. So I just start out by saying, it says I have to start out with a sub 1 is my first term and a sub n is my last term. Well, so whatever my first term is, like in this case it was 3, right? You add the common difference to it to get the next term, right? Like if it was this one, I'd add 3 to it, and that would give me I'd have the original 3 plus the 3, that would give me 6. Now this one, the third term is 9, right? That would be 3 plus 2 times the common difference, right? 3 plus 2 times 6. So I hope that makes sense to you. And this number, like if I wanted to get the fourth term, it'd be 3 plus 3 times the common difference. Notice how this number here is 1 less than the term number. That's kind of what this thing is doing. It's saying whatever this last term is, this is 1 minus it. And I think you can kind of see that. I could have made the pattern go farther for you, but you would have seen the next one was a sub 1 plus 3d, and the next one would be a sub 1 plus 4d. So this is just n minus 1 times d. So this top line right here is part of the answer. That's what they want you to write for letter A. Okay, just write all this for letter A. And this should look familiar to you because I think you've been using this to find the nth term. You can find the nth term in any arithmetic sequence with this. And I think you have been using this. I'm not sure if you recognize that or not. Okay, so so then what you can do, see this n over 2? The next part of, well actually this is part of your answer, and then this is also going to, these two parts are also going to be part of your answer. Because then you're going to go down here, you're going to say, oh, well, to shorten this thing up, I know that these are going to add up to pairs. You know, like this one plus this one will add up to the same amount as this one plus the next to the last one. And it'll work out just like I showed you right here. So that's what the n over 2 is for. And then they just put the first, in this case, that's the first term. In this case, that's the last term. So the nth term, right? So they're adding it up. Because we know we don't need all the other little pieces of it, because we know that if we find out what the first one plus the last one is, like in this case, remember they were all 24. So you just get how many of them there are, divide by 2 because they're in pairs. And then we just swapped this out for a sub n. And you probably already knew that a sub 1 plus n minus 1 times d is a sub n. So there's that. So they want you to write, so what do you write for your answer for A? You write this whole top line. Don't write that little example. And then write this stuff that's in the box. And then this is your formula you're going to use. Hopefully I don't run out of time on this video. That's your formula you're going to use to find the sum of this sequence that they give you in your book. They give you -8, -4, 0, 24. So I already labeled the term numbers on there. The problem is, see, I want to use my formula, but I don't know how many actual terms there are. I've got 3 of them, plus it says ... so I don't know how many that is, but I end up in 24. But I can see easily, if I look, I can determine that it's getting added, 4 is getting added. So D is 4. And so if I wanted to, I could just keep like I can kind of tell that there's going to be 6 more terms, because 6 times 4 is 24, and we're at 0. So I mean, you can just do it that way. You can just keep adding up. Okay, well that's going to be 4, 8, 12, blah blah blah. If you that's not obvious to you, just doing it with common sense this way, or if the numbers are too big in the next problem, you can always use this formula that you have. A sub n, remember that a sub n equals a sub 1 plus n minus 1 times d. That can give me the nth. That can help me find out what n is, because I need n to be able to stick into this formula, right? I have those 2 numbers, I just need n. So so we know that the nth term, actually I already found out it was 9, but if you didn't already know it was 9, you'd put that in, and then you'd put -8 because that's a sub 1, and then 4 is d times n, n minus 1. Anyway, you can see that I distributed. That's where that all came from. Started out here and then I distributed. And then I combined like terms, you can just look at that, I did my algebra, and I found that n was 9. So there's a couple different ways to find that out. Once you find out that that's the 9th term, then you can go over here and plug it in your formula and find the sum of the first 9 terms. So the sum of the first 9 terms is going to be 9 over 2 times, add up the first term plus the last term, -8 plus 24. I think that makes 16. And 16 over 1 times 9. Oh good, that's going to be nice. Okay, so I got 72. Pretty messy. There we go. So let me check that answer before I run out of time. That was number 12. Yep. Okay, it's right. All done.